My name is Jared Hillam, and I'll be moderating today's call. Just a few housekeeping items. We're going to have all the lines on mute so that you can hear our speaker well. Towards the end, we're going to be answering questions through the chat window. And if you have any questions along the way, go ahead and use that chat window. And then when we get towards the end, we'll answer those questions as we wrap up. Any other questions that you have that we aren't able to answer through the chat window? Sometimes this becomes a fairly chatty session towards the end. We can answer those via email if we come up on top of the hour. So without further delay, I'd like to introduce our Katie Kleiner. He has over 25 years of experience working with some of the leading data science and management projects in the U.S. He has a unique mix of technical and business acumen, which is definitely necessary in calculating future demand. So, Katie, go ahead and take it away.
Thank you, Jared, and thanks everyone for joining us this afternoon. This is a pretty important topic, and as you'll see, we have a unique perspective on the way that we forecast demand. Intricity, in terms of background, is focused on helping companies simplify complexity, and we do that certainly through a number of different initiatives, but the most important ones are on the far right. They're focused on planning, forecasting, and running analytics on data that we already have. And obviously the demand forecasting process is no exception. It's critically important. The other two big areas of focus for us certainly are data governance. It's figuring out what master data is around product, around customer, and certainly we do a lot of analytical work that's related to real-time and real-time analytics. If you haven't seen this is certainly a free resource that's available to you. You can simply Google Intricity 101. There are over 1 million views of a series of videos that have already taken place. And certainly we would recommend, if you haven't taken advantage of this, it's freely available on YouTube. And the videos are not technology focused, they're more business focused. So what's data management, what's data warehousing, what's product information master, and certainly many of these videos are relevant to the topic that we're talking about today. I do apologize. I always say this is a bit of an eye chart here. We have customers across a variety of industries, from manufacturing to financial services to retail to pharma and telecom. So certainly any company that collects data is a customer, and we've done some pretty important things across all of these customers and certainly have lots of stories to tell. I pulled out just a couple just to give you an idea in terms of what folks are looking at from a demand perspective. So certainly you'll see a lot of retailers on this list as an example, and we care about demand very closely because we need to understand how much do we keep in inventory. Inventory, keeping things on hand, especially if it's perishable items, is extremely expensive. So space is expensive. Being out of stock is also expensive. And so again, whether you're a medical device manufacturer, whether you're a retailer, whether you're a supplier of any sort of product or service, understanding how to predict customer behavior and what the demand will be is critically important, and that's what this presentation again is focused on. So forecasting demand, there are a number of demand drivers, and so internal drivers sometimes are based on price. So if we increase or decrease the price of an item, that will drive demand. Price is an important driver of demand, and these are things that happen internally based on our pricing strategy. So part of our work with customers on demand forecasting is also on doing price analytics. And so they typically go hand in hand. But if we know that there is a driver and that driver is based on price, we certainly want to make sure that our model incorporates price into our demand forecasting model. The other common thing that you'll have internally is promotions. So you may have a situation where you're running a promotion on a particular product or particular brand, and that will drive demand. And so certainly those are things that need to be in your demand forecasting model. You need to know that there are promotions that are about to happen. Competition on the external side is important as well. So the competitive landscape and a competitor introducing a new product or a competitor exiting a marketplace, those are external drivers, and those are external drivers that we certainly care about. Weather is also a very important indicator. So if we have a rain-out event and we were expecting 10,000 people, certainly less people will show up. So weather is a very important demand driver for us. And last but not least on this slide is events. So these may be world events. These may be events such as Super Bowl or events that might be taking place in your particular geography or in a specific geography where your locations are present. So those are also important external demand drivers. These are just some examples. So certainly there are other internal and external drivers that we take into account. But again, we wanted to share some examples that we typically look at. Those are the top 5 that come across internal and external demand drivers. Demand forecasting today is an interesting field. So we've learned in working with hundreds of customers that there are various levels of maturity that those customers have in the way that they manage demand. With some, it is a very simple formula. What did we sell last year? Let's plan for 10% more than what we sold last year. Obviously not the best model. It doesn't take into account any of the demand drivers. It simply looks at what the sales were in a previous year. As you get further into the layers of sophistication, the next layer that we typically see is a time series partitioned model. Sounds complicated, but most organizations do this very effectively, even with spreadsheets. It's looking at what did we sell that particular week, and let's compare week over week, quarter over quarter. Let's partition it by type of product. Let's divide it by the type of product. So there's a little bit more precision in the way that this model looks at things. The next level is the ERP level. So if you're an SAP customer, or if you have any of the planning tools like Logility or Demantra, you might be using Crofton or Winters models. Certainly SAP does use Crofton and Winters across their planning landscape. These are models that were established in the 70s, and they've made their way into demand planning tools that are available from the big players. The Crofton model typically, and we'll look at some details around that, typically looks at a sparse sales data set. So this is a demand that is not consistent. So these are products that don't sell every single day and they fly off the shelves. These are items that are purchased infrequently. And so as we look at the time period, maybe it's a year, maybe it's 6 months, we'll see that those items don't move the way that the dense items might move. And so Crofton applies to sparse, and Winters applies to dense. And so if you're in that purple box, your level of sophistication is driven primarily by the fact that you have an ERP system. And that ERP system, its bread and butter is to be able to do these very important demand forecasting, run these demand forecasting models. As you go through this process, forecasting at aggregate levels and doing a spread down is another step of graduation. Doing linear regression is another thing that organizations will do. And where we are today, we certainly see everything to the upper left, but where Intricity is today and what we're doing with our customers is we're applying machine learning models to our demand forecasting problems. And so for our customers, rather than simply use the base models that the ERP supports or the basic models that their existing business intelligence tools might provide. We focus on training models based on customer behavior and then using those things that we've been able to train as a mechanism to predict and to forecast accurate product demand. We take into account some of the drivers that we mentioned on the previous slide. So it might be internal drivers such as price or promotions that you might be running, or it might be external drivers such as weather or weather type events, as well as competitive landscape, product introductions, those kinds of things. So the two primary methods of doing forecasting today are based on causal models and time series methods. In the causal model, what we typically do is we look at our ability to say, in this particular example, let's assume that Y represents the quantity that we're trying to forecast. And we're looking at X variables to understand from X1 through Xn, we're looking to understand the predictive power of Y. Is Y a good value that we can use to make predictions? So as we look to see if there is a relationship, and typically it's a linear relationship between Y and the events that might occur and what caused those events to take place. So it's a very, very common approach to sort of looking at forecasting and seeing if forecasting can be done accurately, and we're looking at what is the predictive power of that variable Y. In a time series method, we're primarily focused on looking at collection of past variables, so past values and variables that we're looking to predict. And so the goal is to isolate patterns in historical data. We're looking for trends. We're looking for seasonality. We're looking for randomness or cycles that are available to us in the data set. And so again, you and most of our customers have data. That data is very valuable. And at the basic level, if you're doing things that are before machine learning, those are already important steps. But if you are able to apply the machine learning models that we've built, you're getting much higher precision and much higher accuracy in your models. Data and data patterns that we typically see. We certainly see sometimes random patterns, and so there is no recognizable pattern in the data. And as we're looking at demand and we're looking at time, there is no discernible pattern there. Many times the pattern is linear, and so you'll see these events or you'll see these measures in time collect around a particular linear line. And this might be different for different products. And so our predictive model, our machine learning model, looks at it on an SKU by SKU basis. We certainly will roll it up by category for analysis purposes, but again, the demand planning is down to the most granular item. So if there's a bill of material and it's made up of its subcomponents, and those components are made up of individual components, we will do planning at the lowest grain. Sometimes there's a curve. It might be an exponential curve. It might be a quadratic curve. And again, we're looking for a pattern. We're looking for a way to fit that pattern. And again, seasonal, where we have maybe more sales during the holiday season, maybe November, December, or it might be based on a particular holiday or based on seasonality. As an example, a swimming pool company might have greater sales in the summer months as compared to elsewhere. Certainly depends on the geography that they're located in. The Crofton Method is the one that we sort of mentioned all the way in the beginning. And so these are well-published formulas that, as I mentioned, are used by the ERP vendors, and they can be certainly applied without having an ERP. All we need is a data set. But they're fairly basic. They're looking at forecasting a mean. They're looking at forecasting a variance. And as you can see, the base models go back to 1972, which is when they first were introduced. And the world has changed. We have a lot more data that is of value. And in creating a machine learning model, the machine learning model that we're talking about, the most important thing that Intricity does is we do what's called feature engineering. We go through the process of understanding which features are important and contribute to designing a proper model. That process in itself is an art. And the science behind it is, of course, the machine learning libraries that we use to be able to churn through the data. It is unfortunate that in 2015, everyone still talks about big data, and organizations think that because they are not part of the social revolution, or they're not participating as part of, they don't run large Twitter campaigns, that they don't necessarily have big data. We have customers that are small to medium-sized companies typically, who have big data problems, but they don't have volumes of data. So certainly it's very, very important to understand that in order to do proper demand planning models, we do take into account a large number of variables. And our focus really, as part of our feature engineering practice, is to understand which of those variables have a contributory contribution to getting the demand forecast more accurately defined. And we'll run through multiple iterations, and so the forecast model gets built, and it gets built for each customer independently. We do have a cluster on which this technology runs, but the data that we will collect is different from each and every customer. Perishable items would be treated differently than items that are seasonal, and so on. In the machine learning world, we have a large number of models, and so part of the magic that Intricity brings to the table is to help our customers understand that it's not just the models that are listed on the slide that are important, but how those models are fed. It's the old computer adage, garbage in, garbage out. With machine learning, it's a big danger in not knowing how to properly feed and care for the model in order to be able to get the proper results from it. And so there are models that are supervised and models that are unsupervised. There are models that are categorical and models that are continuous. And so we typically, for the purposes of running demand forecasting models, we're typically in the lower right-hand corner, and so we'll do a number of things for classification purposes and category purposes to be able to run these models. And so CVM, or a modification of CVM, is what Intricity typically applies. But again, it's all dependent on the type of business and the type of items that you're looking to forecast. In a different webinar, we covered customer lifetime value and how customer lifetime value is calculated. Demand forecasting is very different. Demand forecasting not only looks at customers' buying behavior, we're also looking at product, we're looking at product levels, we're looking at a number of different factors in order to train the model and get proper demand forecast calculations in place. The next thing that is important to understand is demand forecasting is an art, but it's also a science. And like any science, it's very, very important to be able to measure what's the accuracy of our forecast. And so typically we will look at a particular period in time, so in this particular example, period T, and we want to know what's our forecast error. So if we know that our actual demand for product was A sub T, and our forecast was F sub T, we want to know what's the difference between the two. How accurate or how inaccurate were we? Is this model predicting things that we can trust, or we can't have trust in the model? And any machine learning or any forecasting model should always be validated using standard statistical methods of validation. And so what we typically will do, and we use all of these methods, we'll do a mean absolute deviation. And so we'll calculate a sigma of these differences divided by time. So if we look at the MAD formula, the sigma symbol simply means that we will be adding these values up, and what we're adding is the actual at a particular point in time minus the forecast at a particular point in time. We take an absolute value of that, and we divide it by t. And t is, again, the number of periods that we look to forecast. So if we did a 6-month forecast, it would be a period of 6 months. And the mean square error and the mean absolute percentage error, also important indicators. And depending on the values our forecast, demand forecast produces for a particular period in time, we will run these forecast error algorithms to measure how effective we are and how accurate we are. Are we overfitting the model? Are we overfeeding the model? And again, that's the science that helps us understand whether the model is accurate and whether the model is providing the value that it's supposed to provide. Ultimately, it's about being able to run the forecast and be able to bring things in line with demand planning. Inventory, as we said at the beginning, there are a number of reasons why accurate demand forecasting is important. If you have inventory, unsold inventory sitting on the shelf that's not moving, it's costing the organization money. It's cash that's tied up on unmoving inventory. And so being able to accurately forecast it is important. If you're manufacturing or creating perishable items, certainly the other variable that's important is anything that you don't sell is spoilage, and that again is money that leaves the door. Other instances are situations where we have stockouts. So we may have an item that where we did not forecast the demand properly and we are out of stock, so we have lost opportunity. All of these are situations where typically demand forecasting becomes critically important. The difference in 2015 to the way that we used to do things in the 1980s is that we have computational power that allows us to do things that were not physically possible or economical to do in a medium or even large size business. Machine learning today is Intricity has a multi-node cluster where we're able to run machine learning algorithms, so clients don't have to invest in infrastructure. You don't have to invest in understanding the data science behind it. But what you do need to invest in is understanding how to best run the business based on the forecasts that we're able to generate. And so as we work with our customers, we help to understand and graduate from the basic forecasting that might be happening in Excel today to models that are much more accurate and much more reliable in being able to predict demand behavior from our customer base. And of course, there are reports and models that the model generates that give us confidence whether we're moving in the right direction or whether we have issues or challenges. And the model continues to evolve, so there may be additional variables that get added to the model. But again, once the base model is built, it becomes really easy to extend it and add additional capabilities to it. And that brings us to the call to action. So certainly experience in doing this for various industries and various customers is very, very important. And one of the ways to take action beyond this call is we do a 3-week strategy engagement with our customers where we look to validate that you have the correct data, you have the initial data set in place, and for us to build the initial demand model so that we're able to demonstrate with the data that we were able to acquire, what does the demand model look like for your organization. And then, of course, this model can then be run and tweaked in perpetuity. So again, the focus is validate goals and objectives, identify where the data comes from, and we do understand in many of these engagements there is data, and sometimes we don't know how to get to it. Intricity's entire business has been built on simplifying that complexity, and so we are your data management partner, so we do know how to get to the data wherever that data might live, whether it lives in your ERP or whether it lives in your spreadsheets. We know how to get to the right data, and then ultimately together defining the demand model and deriving the demand metrics that come off of that model. Jared, if you'd like, you can open it up for questions so we can do, we have, I think, another 15 minutes or so for Q&A.
Okay. So thanks, Katie. And so if you go into the user interface, folks, there's a few questions already, but if you can, in the UI, you'll see a little bubble, and in that bubble you can type a question to Katie. If you post it to the group, I'll just read them off. So one of them that here, Katie, is what is the logical solution architecture?
Logical solution architecture is a visual model of how the data flows. So in order to trust that we're doing, so ultimately a demand forecast is something that has science behind it, and we need to show how do we derive at the values that we did. And so the logical solution architecture is a visual that shows the model in the middle, the users who are using that model on the far right, and then we show all of the sources that the data came from. Did it come from J.D. Edwards? Did it come from SAP? Did it come from other sources that might have been upstream? Are we looking at sales forecast and using sales forecast that might be coming out of a sales planning system? So the logical solution architecture will illustrate all of the data flows from where the data comes from, the model in the middle in terms of what the model is doing and what drivers it accepts, and ultimately on the far right, what do we do with the data once the demand forecast is built? Does it go into our supply chain process? Does it go into our manufacturing process? Who are the consumers of the data, and how does it get consumed? It is a one-page picture that is extremely helpful in being able to explain what we're doing, how we're doing it, and what we've done. And it's also very important because it becomes an important document for the project that shows you exactly how the sources have fed into the model. And so if it needs changes, you now have a base from which to make the changes. Maybe there's a better source that brings in weather pattern data, or maybe there's a better competitive source that we've acquired of competitive data. Maybe it's Nielsen data that might be coming in. So again, I've talked a lot about demand for products. I want to make sure that products are not just physical goods. Many times products have to do with demand for soft goods. So, for example, we're planning on what our demand might be for electronically distributed goods. So, for example, HBO providing shows through iTunes. And so we're planning for demand and what that demand might look like. Even though inventory is not a limiting factor, we're doing it for other reasons. We're doing it for budgetary reasons. We're trying to put budgets together. And so those budgets become very, very important if our forecasts are accurate.
And then there's another one here. Can you talk in more detail about defining the demand model? How is that process done?
Certainly. So the demand model itself, the mathematics behind it, is run on a large cluster of computers. So imagine the way Google runs today. Google has a large analytic engine that figures out how to serve search results to you in the optimal fashion. So we use a very similar cluster mechanism to be able to run analytics and run predictive models across a large set of computers. And so what we would take is we would take actual data for items that have sold in the past, and we might go as far back as 3 years, or longer sometimes, depends on the frequency with which the items are purchased. So the volume and velocity of items is very important for us. And we start to look at what features of the model are important. That's the feature engineering part that I mentioned a little bit earlier. We're focused on understanding what are the internal and what are the external drivers of demand. Is it weather? Is it pricing? What are some of the things that drive this? We look at customer, and we look at to see demographic information about the customer. And so if you think about it, we're feeding all of those into our machine learning algorithm, and the machine learning algorithm is focused on iterating through the data and finding patterns. It is essentially a pattern matching algorithm, and we're trying to fit data to a model. And we're doing it on an item-by-item basis. And so hence the reason for having a large cluster of computers to be able to do this. We use something called GPUs, graphical processing units, and I may be getting a little bit too far into the weeds. But again, our focus is how do we run these models so that they can run quickly, efficiently, accurately, and take in multiple variables. We also run, you might have noticed, Markov chains. We run multiple probability models, so multivariable probability models as part of our machine learning algorithm. And again, it is tuned for variables that we choose to introduce into the model. And so there's a learning process, so the model has to learn from the data, and we teach the model from the data that we've been able to gather. And once the model has been trained, we're able to ask questions of it. As new transactional data comes in, that additional data can be fed back into the model so that we can run a shorter learning cycle. We don't have to retrain it from the beginning. And so think of it as a child learns a language. They've acquired certain skills up to a certain point, and then beyond that, it's all additive. Same thing with these machine learning models. We have a base model. We can store it. We can store the results of it, the neural network that we've built, and then we're able to add to it additional knowledge so that we can run another forecast and perhaps get a accuracy from 98% maybe to 99%.
And then there's one here about marketing. Is marketing planned for based on past marketing events?
So I'm not sure I follow exactly, but if the question is how does marketing help with driving demand, there's typically a direct correlation. So marketing may be running an event. As an example, we talked about an internal event called a promotion. And so we might be running a 10% discount. And that will certainly drive behavior. It will drive demand. And so marketing events are certainly important internal drivers of demand, and those will be considered, and those should be included in our machine learning model.
Okay, that's the last question, Katie. If there are any more questions, what we can do is take those questions offline, and we'll have them emailed out to the rest of the crew that's on. So we appreciate your time in joining us today. Katie, thanks for doing the presentation, and we're recording the presentation today, so we'll send it out to everybody who registered. Thanks so much.
Thanks everyone for participating. And again, demand forecasting has graduated. It's no longer 1970s. We're now in the 21st century, and we certainly have at our disposal tools we've never had access to before that are cost-effective, and the capabilities that it provides are quite incredible. Thanks everyone for joining.